So today we're talking about, well, Git mostly. Git and motors, and I guess solenoids, but we'll get to the motors and solenoids later. So, uh, this assumes that you watched Installing FRC Java and Friends. Um, there's a link to that in the PowerPoint, which I haven't shared with you guys yet. Let me do that before I go on here. This presentation isn't totally thrown together because I spent all day installing a storm door. Oh yeah, I guess you guys can see my lesson plan, but whatever. Yes, TF2. Um, so now that you all have access to that, if you haven't watched this, you probably need to just go watch this instead of attending this meeting. Uh, a bunch of you haven't requested to be added as contributor to our Git repository. Probably means a bunch of you didn't watch this or didn't complete it. Git versus GitHub. So Git is Git is the structure in which our repository is. GitHub is just a company that like hosts that. So, that's just a terminology thing that people get wrong all the time. I've even had like new hires at Cerner mess that up. Git is the program you're using. GitHub is just some company that leverages Git to make money. In fact, Git is open sourced, I'm pretty sure. Yeah, it is, because Linus Torvalds and such. So when you clone a Git repository, it does exactly what it sounds like. It takes the remote repository on GitHub and clones it to your computer. So there's both a repository on your local machine and on the remote on GitHub. You use the git pull command to update your local repository from the remote, to grab changes from the remote to yours. You use git push to push changes from your repository to the remote after changes have been staged and committed. So your Git workflow will look like this a lot. Ideally, if we have multiple people collaborating on the project, we'll have a base branch that is the dev branch that we all work out. So when you get an assigned task, what you'll do is, assuming that you've already cloned the repository to your computer, you'll move into that folder in Git Bash and do git checkout the name of the base branch, so dev, to make, and then do a git pull to make sure you have the most up-to-date version of the dev branch. Because I actually want to go do this. If I go to documents, bot, oh, not untitled, bot, infinite recharge 1806. So, this is already cloned, but if it wasn't, you'd do the git clone command on GitHub, and I'll just show that. I'll just make a get back here, go to go to github.com/frc1806. Go to repositories, infinite recharge 1806. Copy this link. Open a git bash here. Git clone, paste. And then, how is my CPU at 100%? That's, oh, OBS Studio is just absolutely wrecking it. Oh, I think I know why. Yeah, OBS Studio is super ultra weird sometimes. Yeah, it's back down to 10%. Anyway, we got that. Then you go cd infinite recharge 1806, and I just use the tab key to autocomplete there. And git checkout dev. Git pull. Already up to date. Someone's pinging my phone. It may actually be me who pinged my own phone by sharing the PowerPoint. Yep. All right. Anyway. Ah, dang it, I lost the game. Anyway. So yeah, we've got dev, and then you do like git checkout -b climber. So this is a kind of like multi-command grouping into one. What that this git checkout -b creates a new branch based on the current branch. So creates a new branch named after what you're working on based on the current branch and checks it out. Anyway, git branch. So yeah, that git checkout -b is the same as these. There's just git branch task name, git checkout task name. So that creates a branch for your task. Every branch, so now what? Make save code file changes, and then you have to stage your commit using these commands. I mean, you guys have the PowerPoint, you can see what that looks like. Git commit and then get pushed. No one ever remembers that command. So once you, so when you do all that, you'll do a, once you have your commits up on the remote, you'll do a pull request, review the changes. Once it's been reviewed by 2 people or after 1 day, you can merge it, and there'll be a button there. This slide probably should have been at the beginning. Git is a way to track code. Allows multiple development branches to make collaboration easier. Cross-platform. It stores changes to commits. This is just a hack if you make changes on the wrong branch. You'll see that up later. Not to change your branches, but you have local branches. You can use the git stash command to be a place where things go to die. But you can also use it to get back the changes that you stashed here and that. Oh yeah, merging. So if when you do your pull request, there's a thing called a merge, and if the merge can't be done automatically, ask me about it. I'll help you out with it. Merging is a really annoying process. It would take longer than any meeting that we would ever have to explain it. Oh, so dev is the main branch that we work out of, but I will handle merging to master once we've tested our code. So dev will be an unstable branch that is not guaranteed to work on the robot. Main should be guaranteed to be functional code. So what we're gonna do is I linked a couple of documents in here. Double solenoid, Spark Max API. And just kind of actually I'm just gonna search for can Spark Max. Because we're gonna need to use one of these. Double solenoid, we'll need one of these. Let me move these off the side for now. Then VS Code. Open folder. I'm gonna switch over to my sample folder. We're gonna go into source main FRC 2020 subsystems. And I'm going to make a new hypothetical subsystem. Right click on subsystems, hit new file, climber. Right click subsystems, climber.java. First thing I'm going to do is I'm going to go over here and copy this package declaration when you're have to delete 400 Git VS Code. Well, that's sounds like a you problem. No offense. And then what I'm going to do is I'm going to make this climber. So there's some very important implications about this extend subsystem. What we have here is we have a file that declares what package it's in. It says it has a public class climber that extends the subsystem class. We right click, go to definition. You can see this interface, and by doing this, we have basically agreed to implement all these functions. So first thing is public or so we only want one climber to ever be on the robot, right? So private or the client equals new client. Public climber Git instance actually I'm going to what the heck are you doing, Visual Studio? Anyway, so this is guaranteeing that there will be a singleton climbers and only this code will only have one instance of the class ever. So then we're going to make a private constructor. So I guess let me backtrack a little bit here. Avoid getting copyright claimed. Gonna avoid getting copyright claimed even more. Let's see, somewhere in here. So here is the climber that we're looking to replicate in our code. So they don't show it here, but those hooks could move up with pneumatics and then are driven up and down by a motor. Or it may be pneumatics and then a spring release and a pull down. It actually, yeah, it probably is just they probably release at the same time. I don't show it somewhere in here. Yep, that's spring loaded. By the way, 148 is a really good team. Okay, let's go Blue Alliance 48 2020. Oh yeah. Actually, as a side note, while we're in here, I saw that they're showing 2022 season. Okay, never mind. The Blue Alliance is broken. Wait, what? That's not. Okay, yeah, Blue Alliance is broken. They're working on pulling in the 2022 season. But if you haven't heard, we're going to Oklahoma next year. March 9th through 12th. Let's see, end game. So yeah, so that goes up, and then that goes. That's not spring loaded at all. They must have changed that later. So yeah, we're gonna make code to have a subsystem that can do that. Whatever actually get implemented on the robot, probably not. But it's the easiest example I could think of. So, looking at that, we're going to have a private Spark Max and Spark Max. So we're going to declare that up here. We're also going to have private so yeah, we've got our motor and our solenoid, but they're not initialized. So we need to, in the constructor, equals new. Excuse me for 1 second. Anyway, so Visual Studio is being annoying. I'm going to copy this import over. To be able to use the CanSpark Max, you have to import it. Visual Studio is being very, very dumb right now, so it doesn't realize that it should be suggesting these things. I'm also going to grab the solenoid. So yeah, CanSpark Max is a motor controller for a Neo. Double solenoid is pneumatics, in out, air powered thing. And I noticed a capitalization problem. And let's just say the ID for this is 25. I think. Well, okay, yeah. Oh, motor type.k, bro. Right. Motor type.k. Again, this would usually be a lot easier because autofill would be working. But, it has abandoned me this evening. Right. Need I'm going to restart Visual Studio. I think it is. See if importing the project helps. Yeah. That's why. So if you ever have your autofill not working, that's why. Yep. Okay. Motor solenoid. So we have a climber. It exists. It has a motor and a solenoid. But hey, remember when I said there are some implications to implementing subsystem? This is not a valid class yet. We have to implement the methods that we agreed to by saying that we extend that subsystem. Top would just be motor dot set 0. System output telemetry. Yeah, we don't need that. So this is now a valid class. It doesn't really do anything other than just exist, but this is the valid class now. Oh, and notice the override specifier. That's just saying that it um, takes priority over the methods in the base subsystem class. Plus, we need to add some of these, actually. We're not going to need that because we don't really read periodic inputs, but write periodic outputs we do need. And so we're actually going to need to add override to all of these. Also going to have to fix the formatting because that somehow got absolutely destroyed. So yeah, grab that, Control C, paste it, import the thing that didn't have. And I'm going to go cheat off of an old class. So the looper is what gets run. Actually, I'll explain this later. Basically, this looper has functions that get run every loop of the robot, so to speak. So to speak. So I'm just grabbing that code. So, you know, a looper has on start, on loop. I think that's on stop. Yep. Oh, wait, so this actually needs to be tabbed over. To import it. Ah. Oh, in. There, we grab the enabled looper that gets passed in by the subsystem manager, and we register this new loop that we're defining right here. This is like basically an anonymous loop. It's an unnamed custom defined loop. Java is weird sometimes, but you know, this whole new loop, and then you just like define the whole thing down here. I'm missing a SIM. There we go. So yeah, so we'll deal with this in a bit. Zero sensors. We're not really using sensors for this. What we need it to do is define a custom enum. Public timer state K folded K unfolded K disabled. So what we're going to make here is a state machine. I'm gonna make sure we did. Okay, state machine's in here. So what we're going to do is on loop, we're going to do a switch statement. Well, actually, we're going to first, got a little ahead of myself there. Private climber state. And the reason this is private is we don't want anything just randomly changing the state. So this will actually, I'm on climber, I'm on the constructor equals climber state k folded. So I'm going to make sure that the robot starts out, that the climber runs like right when the robot, or the constructor runs right when the robot starts. We're going to assume the climber is folded. Why is that important? Well, so there's a rule about how far you can extend outside your robot in the horizontal plane. And so if you have your climber hold it up like 148 does there, and you move the motor out, you're going to get a penalty. So on loop, we're going to switch on climber state. So we're going to make a default case and I can't spell default. So the switch is going to read the current climber state and then do which code down here gets selected. So like if it's disabled, what you do is so you make sure to set the motor to a value of 0, which is to stop and break. If case climber state dot a folded, if it's folded, what you do is you motor dot set 0. Break. So if you don't have these breaks here, it will continue like executing down below. So you have to have these breaks here to get out of the switch. What are you complaining? Oh, it doesn't like that I'm doing that. Case K unfolded. Set. Now we're getting into things like private double wanted motor demand. Equals 0. that'll just set the motor to 0 on start. Let's set wanted motor demand. And then, well, yeah, and then so what we're going to do is actually also need another variable, private double last wanted unfold. Do last wanted unfold 0. Oh yeah, wait. Last timestamp. What we're going to do is we're going to save off this timestamp. Is how things are going to interface with this. We're going to do public void want unfold. Void want fold. Immediately we're going to set climber state to folded. And I just, yeah, used autocomplete and used tab to complete that. What we're going to do here is last wanted unfold equals last timestamp. And we're going to do double solenoid set k forward. Value.k forward, and then when we fold up, value.k reverse. Forward will move the arms up, reverse will move them down. So it's going to take time for it to fold out high enough to where we can start moving the motor. So what we're going to also do is add a new constant. Just public static double k unfold time equals, let's just say 1 second. What we're going to do is we're going to do log the timestamp, and immediately in every loop we're going to check the solenoid if get equals value.k forward. So if the solenoid is currently forward, if timestamp, actually, I'm going to simplify this a little bit. I'm going to do a Boolean and with timestamp greater than last wanted unfold plus constants dot k unfold time. So this will make it take a full second before the motor is allowed to move. So disabled, don't move. If it's folded, don't move. As soon as you've unfolded it for the first time, that arm can be anywhere. That way we can get the robot itself to time its own unfolding. So that we're not having a human sitting there like waiting to move the joystick until it's up. This is, we have a static known how long it takes to get the arms up, and it will just be consistent every time. We'll try to get the arms up as soon as we can to go climb. So, and then we'll do is we'll add a void set wanted demand double power. So yeah, so this can be called all the time in Teleop, and the driver can be moving the joystick all they want, but unless we're in the unfolded state, we can't. It won't unfold. We actually don't need any of these functions right now. So yeah, I think that's actually oddly enough it. So we've made our changes. I'm not gonna simulate them right now, but we're gonna go back to Git. I'm gonna do a Git status. Look, we've updated constants, cache properties, and climber. Cache properties. So if I do git add -u and then do a git status, you'll see that everything that was in this changes list was staged for a commit. And if I add hold on, select that, right click, copy, git add timer status. Yep, commit action added timer. So I got a question for whoever's still around. Did what I just did in making a commit update GitHub? I'll give you another 30 seconds to answer that. Okay, no. The making a commit did not update GitHub. We go to our repository on the internet. You can see that there's not even a climber branch here yet. So what gives? Well, if I do git push, well, it's gonna tell me to run this command. And look, it updated in real time. Timer had recent push less than a minute ago. So say that was done and I like tested it. I'm gonna go over here. I'm gonna change my base to dev because we're not running out from dev. Timer, create pull request. So it can merge automatically. That's good. But you know, you need reviewers. So you go up here and you could add like me, you could add Evan, you can add some students that have graduated or moved. So I'm going to add myself as a reviewer in this case, because you should always add me as a reviewer on your pull request. So it's going to say one pending reviewer. And then hold on. This is taking a bit longer than I anticipated. Hold on. Well, anyway, this, if you had an approved uh, reviewer, you'd hit this. But also someone could ask for changes and you can update them here. So yeah, that is all the meeting. So I guess are there questions? I guess not. So oddly enough, we're done for tonight. See everyone Tuesday for the all team meeting. Later.